Hello, everyone. So on to session 3, hypertrophy and intervals. Just a heads up, of course, you may have already covered some of this content in class. And if you really just want to see the examples, feel free to just jump ahead to the end of the video where I'm working through the examples. Otherwise, you can just kind of watch this to make sure that we're on the same page, and hopefully it's helpful. So just to start with, I'll show the PowerPoint first. All right, so hypertrophy and intervals. So our outline for today is we're going to talk about the hypertrophy of the atria and the ventricles, what it is, the criteria, what to look for in ECG. And this is probably a little bit redundant, but same idea for each of these. So then we're going to look at bundle branch blocks, left and right. Wolff-Parkinson-White syndrome, since it's very kind of similar in appearance to a bundle branch block in a couple of ways. And then we'll do some practice from the week 3 assess.med cases. Just to pull up the ECG cheat sheet so that you're just familiar with what pages we're working on. So hypertrophy right here. So we're going to be working through this little section, and then right and left bundle branch blocks. And if you go to the kind of additional helpful diagnostic criteria, where is it? Oh yeah, here it is. Wolff-Parkinson-White, so ventricle pre-excitation syndrome. So let's go back to the PowerPoint. All right, so hypertrophy, so basically it just means enlargement of the muscle, and there's 4 possible regions. Atrial, which would be left atrial enlargement, or the right atrium, which would be right atrial enlargement. And the best way to find those is looking at the P wave in lead 2 and V1. Ventricular could be in the left ventricle or the right ventricle. And then you're going to see a very large QRS wave. So when we're looking at the atrium, one of the criteria that's kind of commonly used is if it hurts to sit on, it's probably atrial enlargement. So pointy or really big. So left atrial enlargement stands out, not as much in lead 2 if this is a large second hump, I mean, perhaps. However, lead V1, the precordial lead, really shows this inverted P wave, which stands out when you're reading the ECG. Right atrial enlargement kind of is more of that it hurts to sit on kind of appearance. It looks either really big in lead 2 or really pointy in lead V1, and it doesn't have that inverted piece to it. So this is from Lily's, and then you can see here, this would be looking at lead 2. So the right atrium, it gets bigger. And then in the left atrium, it would also look bigger in lead 2. So it's not quite as helpful, but you could see it there. And you're looking for that P height being greater than like 2.5 millimeters. So like 2.5 little boxes. Versus in lead V1, if it's the right atrial enlargement, it usually looks kind of pointy. And if it's a left atrial enlargement, it actually looks inverted. So left atrial enlargement is usually quite easy to pick out. This is just a table summarizing. This would be P pulmonale is just the right atrium, and then P mitrale is the left atrium enlargement. And you can just kind of read through this table on your own. Ventricular hypertrophy, we're just talking about the ventricles getting larger. So it's essentially saying that the amount of like depolarization towards the lead is increasing. So if they have a right ventricle hypertrophy, the R is greater than S in lead V1, which would be unusual because we usually have a bigger S. And then if it's a left ventricular if it's right ventricular hypertrophy, R is greater than S, and there would be a right axis deviation. Versus a left ventricular hypertrophy, you have to kind of summate 2 different leads. So usually you do like V6 and V2 or V6 and V1, kind of depends. And if it's greater than 7 large boxes or 35 millimeters, that would be diagnosed. Well, that would be the criteria for a left ventricular hypertrophy. And you can see here, it's like this really big S wave in V1 and a really big R wave in V6. So going through that again, so if we are looking in normal, so V1, little R, big S, and then V6, it's a little Q, a big R, and almost no S. Versus in left ventricular hypertrophy, we see a really big S in V1, a really big R in V6. And with right ventricular hypertrophy, we're going to see a large R, which is unusual in lead V1, and then that S is going to appear in V6. Well, it's always going to be there. So it's just kind of showing that that side of the heart is enlarging. There's also, of course, we talked about the axis deviation, something called upside down or upright hockey sticking. Essentially, it's going to look like a kind of like a whoop right here, like a hockey stick with a curve. It's going to be kind of, I think it's concave is the shape that they describe it as. Essentially, it just kind of stands out as a weird repolarization, or kind of just after. So if we look at some more pictures, this would be the left ventricular hypertrophy. So if we look at this, so lead V6, and you see these boxes circled, so it's showing that it's enlarged, and then lead 1. So if we added this up, this would be, let's see, 1, 2, 3, 4, 5, 6 boxes. And this one is 1, 2, 3, 4, 5. So 11 boxes, so way more than 7. So that meets the criteria for left ventricular hypertrophy. Versus over here, this is another criteria that you could use for the left ventricular hypertrophy. So I haven't used this one as much when I was practicing in cardio block, but it is another possible one. V3, you could be going down, so R in AVL, and then S in V3. So S in V3, so 1, 2, 3, 4. And then over here for AVL, 1, 2, 3, 4. So that's 8. And here it says we only need about 4 or 5 boxes. So well over the criteria. And then this one I have used a couple of times. It comes up a little bit more often. So if AVL is just greater than 11 millimeters, so just over 2 boxes, so you can see 1, 2, 3, 4 boxes, it's definitely over 11. This would be almost 20. So axis and deviation. So if you have a left axis deviation, you're going further away. So that means these leads, the inferior leads like AVF is going to be negative. So you're going to be having more like a left ventricular hypertrophy. And a right axis deviation, you're moving over to this side of the graph. And that would mean that you have lead 1 being negative, your lead AVF being positive, and that's a right axis deviation. So just looking again at another example. So if we looked at a normal heart, so again, small r, big S, and then larger R in V5, V6, small s, if any. Left ventricular hypertrophy, this kind of exaggerates that S and that R. Versus right ventricular hypertrophy, we gain an R in V1 and V2, and we also gain an S in V5 and V6. So over here, we're looking at what that looks like, left ventricular hypertrophy. It's a large S in V1, large R in V6, and right ventricular hypertrophy, we have a R appear in V1, which is abnormal, and we have an S over here in V6, which would be abnormal. All right, and then this is just some tables just to kind of describe that again, which you can look through on your own time. And this would just be kind of a summary of there's a right atrial, left atrial enlargement, left ventricular hypertrophy, right ventricular hypertrophy, and there's the various criteria, and then there's various causes for it too. So strain kind of stands out when you're looking through hypertrophy. So it might not be if you're learning about, STEMIs and like ST elevations, which is what that stands for. And you could be thinking like, man, is this an MI? However, if you're looking with hypertrophies, you want to be keeping in mind, is this just a strain of the heart? So essentially it makes it look like when there's a depolarization abnormality, like hypertrophy, there's a repolarization abnormality, which would be strain, the ST segment. So here, strain, consider if left ventricular hypertrophy is present if this strain is present in multiple precordial V1 through 6 leads. So you're going to see ST segment elevation or depression, and it's usually opposed to the QRS, so it's a discordant. And it's proportional to the size of the QRS, and it's concave, which is kind of the phrase used like hockey stick. So it's got like kind of a happy face, I guess you could say, for the concave. And again, saying with this, the T wave is inverted, so it goes away from the QRS. And it's asymmetrical, that's not going to be quite as obvious, but the fact that the ST segment is kind of out of its usual location and the T wave is going the opposite direction of the QRS complex, and there's hypertrophy, then you're thinking this is probably strain, not so much an MI. And to differentiate it here, we even have a note: in an ischemia or an infarct of the heart, ST segments are like flat. So instead of being like a happy face, they're just straight. And they're not proportional or related to the QRS direction. So they could just be elevated, even though the QRS could be going whatever way. And it doesn't change. So if it had a really big R wave, you're not going to see a really big T or ST depression. It'll just be like kind of the same. So that'll give you a hint that's not strain, it's something more serious. And left ventricular strain can make a STEMI hard to read, which is generally why you read the hypertrophy before you read the ST segments. For that acronym that we use, rare steak barbecue with Sterling, because rare steak, so rare hypertrophy, and you're checking the hypertrophy before you get to the barbecue. The Q is the Q waves. And here's just another picture demonstrating strains. You can see it's usually in the opposite direction. It's concave and it's proportional to the size of this QRS. And you can see this one's bigger, so it gets even bigger. And same with this guy. And then over here, it starts to flip in direction. So the R wave, and it flips the other way. And then the magnitude of ST changes are proportional to the size. So just what we were saying again, you can see this QRS is bigger, the ST change gets bigger too. And it's concave away. So you can see there's these little happy faces. So it's concave, 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 and then little unhappy faces. So down here, frown, frown, frown. So just in summary, the ST segment in strain usually shows that it's going away from the QRS, it's proportional to its size, and it's concave away, AKA hockey stick. And here's just another picture summarizing the left ventricular and right ventricular hypertrophy. And then this is just kind of summarizing the abnormalities of the T wave, which you'd see in that hypertrophy. And you can just look through this on your own time. So non-conduction in the heart. So you know the SA node would depolarize, goes through the atrium to the AV node into a delay, and then the bundle of His fires through the Purkinje fibers, the ventricle contracts. And then we get the PQRST. And so I already described that, but just SA node, AV node, bundle of His, Purkinje fibers. So bundle branch blocks are essentially when half the bundle of His is no longer firing. So if we went over here, if this guy got cut off, this would be a left bundle branch block. And if this one over here got cut off, it'd be a right bundle branch block. And with a bundle branch block, you're going to get some very weird looking waves. So here we have a right bundle branch block. And essentially it's just showing how you end up with this deviation. But what you really want to focus on is that with a right bundle branch block, you get like what looks like rabbit ears in lead V1. So you can see ears, versus with a left bundle branch block, with the way that the depolarization goes, you end up with kind of like a mountain peaks in lead V6. So what you're looking for is rapid ears in V1, right bundle branch block, or mountain peaks in V6, the left bundle branch block. And you're also looking for a wide QRS complex. So when you're going through your rate axis rhythm intervals, when you see a wide QRS, your ears should perk up to then look for bunny ears or mountain peaks in the lead V1 or V6. So left bundle branch block. So we have an R wave in V6 over here, and you can notice that's notched. So it goes up and then up again. So it looks like a mountain peak. And then in V1, it starts negative because of the right to left kicks, like notch up. Yeah, generally it's not quite as obvious, but you can just kind of tell it's larger than the couple, like few boxes that should be. And then you look for the bunny ears. And then over here, you can notice in lead 2 that has a leak amplitude because of the change in the depolarization. But honestly, like you could look around, like look at this lead one. It's like it's really wide and it's got mountain peaks there, and over here it's really wide. So this is it. This tells you that's a left bundle branch block. And then right bundle branch blocks, it's got rapid ears. So as soon as you see that wide QRS somewhere, perhaps it's not quite as obvious in this graph. Well, this is pretty obvious. It looks weird. You can see RSR, and that tells you, hey, this is probably right bundle branch block. This is a summary. And so there's a little mnemonic to remember it. So it's called William Morrow. So in a left bundle branch block, the QRS looks like a W in V1. Now, I don't find it's helpful. An M in V6, which is the mountain peaks. In right bundle branch blocks, the QRS looks like an M in V1. That's the bunny ears, which is very easy to see. And W in V6, perhaps easier to see the M. And this is just another picture from the latest just showing its explanation. So you can look through that if you want to see how that works. And I think this is the last thing that we're talking about for info is accessory pathways. So essentially your usual path is from the SA node through the atria to the AV node, through the bundle of His into the Purkinje fibers. However, there can be things called like this bundle of, I think this is Kent, not just Kent. And it's an accessory pathway. So it goes around the atria, but then it finds an extra way into the ventricles. So it bypasses the AV node and it results in an accessory pathway. So basically one of the syndromes that is associated with this is we call Wolff-Parkinson-White syndrome. So you can see how this charge is able to go around and into the ventricles without going through the AV node. And the way that we see that on the ECG is that we see a P wave that's got a very short interval. We see a delta wave that's kind of weird. It's kind of like a slow rise almost immediately after the P wave. So, and that results in a wide QRS, and then everything else is normal. So short P wave, wide QRS with this kind of delta wave, you're thinking Wolff-Parkinson-White with this accessory pathway. And so this is just another picture showing that. So you see a P, short PR, delta wave with a wide QRS. And you can just look at this. So this just, again, describes Wolff-Parkinson-White and things that you're looking for. So we're on to practice. So this is the ECG cheat sheet for the stuff that we covered today. So I'll just go through it briefly. So hypertrophy, and you only need one of the criterion for the hypertrophy to be met. So atrial enlargement, you're looking for painful to sit on, and you're really checking lead 1 and AVL. So for the left atrium, it'll be inverted in V1, and it needs to be about 1 square wide and high. And you could see lead 2 as a notched M. Not as easy to tell though. Right atrial enlargement, you're looking for greater than 2.5 millimeters height and pointy in lead 2, or V1 really spiky. This is actually a really good one to look for. And then if they're both enlarged, the P wave is going to last more than 3 small boxes, 0.12 milliseconds, and it's elevated in lead V2, or lead 2, not V2. For ventricular hypertrophy, so we're done with atrium, ventricular, we're checking leads V1 and V5 and V6, and we're also looking for strain, which is those ST segment changes, hockey sticking. So if it's a left ventricular hypertrophy, you're looking at S in V1 plus the R in V5 or V6. And if it's greater than or equal to 35 millimeters, 7 large boxes, that would be hypertrophy in the left ventricle. You can actually choose between 1 and 2 and 5 and 6, but you try to keep a diagonal line. So if you choose V5, try to choose V1. If you choose V6, you can choose either V1 or V2, because you just want to make sure that you're kind of keeping some distance between the two. So a diagonal line. Consider left ventricular hypertrophy if you see your left axis deviation when you're kind of doing your, rare, so rate axis rhythm intervals. And then other criteria you can use is an R in AVL greater than 11, an R in lead 1 greater than 15. I haven't seen this one much, but I'm sure it's out there. R in AVL and S in V3, which was greater than 28 or greater than 20 for men and women respectively. And then right ventricular hypertrophy, you're looking for that R wave being a lot bigger in V1 than the S wave. So R greater than S. And you can also see if the R wave is bigger than 7 millimeters in V1. Generally, you're kind of just looking for the ratios. And if you see a really big R wave in V1, that should already be telling you, hey, this is different. And then on top of that, if you see an S wave, so R less than S in V6, so you see like still a reasonably sized S wave, then you're thinking this is right ventricular hypertrophy. So going from V1 to V6, you should see the R wave becoming progressively smaller, which is abnormal since the R wave should be getting larger as you go from V1 to V6. And then of course, consider right ventricular hypertrophy if you see that right axis deviation, and you might see some right atrial enlargement and maybe a slightly widened QRS, maybe. Strain. So if you're seeing left ventricular hypertrophy, kind of your antenna should go up, you're looking for strain. And if it's present in like all the precordial leads, like V1 through 6, that's probably strain. So you can see ST segment elevation depression, and it's proportional to the size of QRS, it's concave, aka hockey stick. And the T wave is inverted, which is kind of what we've been talking about. And it's going away from so that means it's going away from the QRS, and it's kind of asymmetrical, which just kind of stands out when you see it. And then we talked about this earlier. So in ischemia infarct, we haven't talked about this yet, but we'll come back to it later in our lesson. And the important thing is left ventricular strain can make a STEMI hard to read. So you do hypertrophy before you do Q waves. And another section, so there's actually quite a bit in this lesson, but we're going to start with hypertrophies mainly. So actually, we're going to do some on-the-fly editing here. All right. There we go. Okay, so here's the practice cases. So it's from the week 3 ECG practice hypertrophy from assess.med. And the cases I went with are questions 1, 3, and 10. So question 1. So here you can pause if you want to try to work through it. And then I'll work through it right now. So rate. So let's just do the 10-second count. So 1, 2, 3, 4, 12. So rate is 12 times 6, so 72. Axis, so this one's up, that one's up, so it's a normal axis. Rhythm, I see a P, QRST, P, QRST, P, 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 P. Looks like normal, looks like a sinus rhythm. Intervals, the P, so let's find where the P links up. Here's pretty good. So it's kind of borderline. You can see it's like 0.2. I'd still say it's normal though, so normal PR. And then QRS definitely looks normal, so normal QRS. And then QT, that's less than half, so normal QT. Okay, so now we're looking for hypertrophy. So we're looking at right atrial enlargement, left atrial enlargement, left ventricular hypertrophy, right ventricular hypertrophy. So when I look for the atria, I start over here in lead 2, and this guy looks awfully tall, so that doesn't look right. And hey, this one's inverted. So inverted, I'm thinking left atrial enlargement. And this guy would have to be really wide for me to think he would also be a right atrial enlargement. So I'm just going to stick with left atrial enlargement. And so I'm done with the atria. So let's look at the ventricles. So if I'm looking at the ventricles, I'm looking for left ventricle is really easy to see. So if I look at V6 and I counted, so let's see, 1, 2, 3 boxes, and I went with, let's say, V2 here, 1, 2.5. So that'd be 5.5, and the criteria is 7. So that's not enough. So I don't think it's left ventricular hypertrophy. And right ventricular hypertrophy, I don't see a big R wave here, and there's not much of an S wave in V6. So I don't think it's either of those. So let's take this to the next page and see how we did. And here we go. Okay, so rate. Yeah, sinus rhythm, 72 beats per minute, normal axis, borderline PR, but yeah, it's normal, but it's definitely kind of long. Good QRS, and it looks like they're saying there's a little bit of an R wave here, so it goes R, S, R. So incomplete right middle branch block. Fair enough, but the QRS isn't wide, so it's not like an actual full bundle branch block. Normal QT, check. And left atrial enlargement, and we can see that nice negative P wave in lead V1. Okay, so question 3. So go ahead and pause, and then we'll do this one. So great. I'm just going to do the 10 count here. 1, 2, 17. So 17 on 6 is 60, about 102. And then axis, looks like it's the left axis because this guy's going up, but this one's going down, down. Yeah, definitely left axis. Rhythm. This rhythm is a little bit more obvious over here. So I see P, like this looks like the T inverted, P, Q, R, P, Q, R. Yeah, so there's definitely P waves first. So looks like sinus, well, maybe a sinus like tachycardia. Intervals, it looks about like a normal interval. Maybe touch close to long, but it looks like within the box. I'm going to say normal PR. Oh, that's definitely a wide QRS. It does not look normal. And then a QT. It looks like it's, I mean, I think it's a little bit easier to see down here. If this is that QT, it looks like it's less than half. So I'm going to say normal QT. All right, so I have a left axis, so I have an axis change, and we also have a wide QRS. So now my, I'm going to do hypertrophies first, and then I'm going to come back to the bundle branch blocks, sticking with that acronym, rare state barbecue. So rare state, so right atrial enlargement. I don't see anything here in lead 2, so I'm not going to bother looking at that much now. But over here, I see a really pointy P wave. So pointy P waves, painful to sit on. It's an enlargement, and if it was left atrium, it'd be going down. But since it's pointy going up, I'm thinking right atrial enlargement. So right atrial enlargement. And yeah, there's definitely no ventricular hypertrophy from the left ventricle. From the right ventricle, though, this looks promising because we see a nice big R wave over here and a nice big, well, a predominantly S wave in V6. So query right ventricular hypertrophy. It probably is. However, this wide QRS might be throwing that off because we see this RSR, and you know what that is? That's bunny ears. So bunny ears means a right bundle branch block if it's in V1. All right, so let's take this to the next page, see how we did. All right, so sinus rhythm 96. Well, okay, I got 102, but perhaps we count a little different. I got left axis, yeah, it's the same, ignore the S wave. Normal PR, yeah, right bundle branch block, yeah, we got that. Normal QT, yeah, we got that too. Right atrial enlargement, booyah, looks peaked, it's painful to sit on, that is right atrial enlargement. And then query right ventricular hypertrophy because it's really big, and yeah, this S wave over here. So nice, looks like we nailed it. All right, so next question. So go ahead and pause, work through it, and then I'm going to start over here. So 6 on 13 is 60, 78. So rate 78. My axis is normal. So up and up. My rhythm looks like there's a P, QRS, T. Man, T is really far away. P, Q, QRS, T. Yeah, it looks like a pretty steady rhythm. No drops like QRSs, so looks like a sinus rhythm. And then intervals. So the PR looks like, it looks pretty normal. Like that looks like it's within a box for sure. So I'm gonna say normal PR, and the QRS looks narrow, so normal QRS. It's within the, like, I mean, when you have a normal QRS, it just looks nice and pointy. This guy looks pointy. And if it was wider, then I could try to count for like a couple more boxes. So if it was like just over 3 boxes, then I'd be thinking wide. QT, long QT for sure. It's definitely over half. Right rhythm axis. So hypertrophy. So we're going to start with the right atrial enlargement. And maybe something's kind of looks different here. but it's inverted over here in V1. So I'm thinking left atrial enlargement. And then how about the ventricles? Oh yeah, look at this guy. So looking at the left ventricle, look at this. So you go 1, 2, 3, 4, 5, 6, at least 6. And if I took even, if I just even look at V2, this is obviously huge. 1, 2, 3, 4, 5, 6, 7. Yeah, I'm well over the 7 boxes. So left ventricular hypertrophy for sure. And great. Okay, so now we're on to the bundle branch blocks. And the QRS was normal, so I don't think there's any bundle branch blocks here to look at. All right, so let's have a look at this. So sinus 85, again, sometimes I find the counts are a little bit different, but I'm close, it's within 7. Normal axis, booyah, borderline long PR, yeah. Borderline long QRS, maybe, looks kind of pointy to me. Long QT for sure. Left atrial enlargement, yeah, we got that, it's inverted. Left ventricular hypertrophy, yeah, definitely. Oh yeah, hockey stick changes. So if we're looking at this, you can see this looks elevated. It's got that concave shape. It's going away from the QRS and it's proportional to its size. So that's when we're describing strain. Right now, we haven't really expanded our full acronym out. And so once you start looking for the QRS-ST changes, strain becomes a little bit more important to recognize. All right, so that's kind of it for the hypertrophy section. That doesn't mean hypertrophy stops being important in your little acronym. So now let's do bundle branch blocks. So examples from the week 3 ECG practice intervals, bundle branch blocks, and Wolff Parkinson White. Keep that in the back of your mind. So we're going to work through example 5, 6, 8, and 11, and the rest you're able to do on your own. So the cheat sheet, so right bundle branch block, you're suspecting if there's a wide QRS. Same with the left bundle branch block. If there's a wide QRS, ears go up, you're looking for bunny ears or mountain peaks. So if you see an RSR pattern in V1, like an M shape, that is with a wide QRS, you're pretty well done. That's right bundle branch block. You might see a wide S wave in V6, perhaps. You might see, this is not intrinsic coid, this means kind of like a slow start, if I remember that correctly, but it's not really as helpful as this. And you could have ST depression in V1 through 4, which would be a sign of right bundle branch block. This is kind of specific, but ST elevation in V1 through 4 could still be a STEMI. Not important this week, important later. Left bundle branch blocks, suspect there's wide QRS. You might see a W shape in V1, but the big winner is the big R wave M shape in lead V6. You might also see it in some other leads. You might see this kind of intrinsicoid, which is, I think, is the slow start. But basically, once you see a left bundle branch block, you're kind of done because it throws off the rest of the ECG reading. So you're not really looking for anything else. And then Wolff Parkinson White, ventricular pre-excitation syndrome. So this is when we had that kind of the accessory pathway around the heart. So short PR interval, a wide QRS, and that delta wave right at the start of the QRS, which makes it wide. And then you're done. So let's do example 5 here. So go ahead and do the example, and then I'm going to start working through it here. All right, so I got a rate of 54. I got our left axis. It looks like it's a sinus rhythm, bradycardia. For intervals, this PR is definitely long. That is really long. So long PR. QRS looks wide. And I could count it. I could try to count it. It looks like 1, 2, 3. You just, by kind of looking at it, it just doesn't look nice and sharp. So it's definitely wide. Like it should be like almost instant. And then QT less than half, so normal QT. Hypertrophies, so over here, yeah, it doesn't look like it's inverted, and it definitely doesn't look very pointy, like maybe a little point, but definitely not high enough of a point. It's so small. And there's like nothing over here. So, and then left ventricular hypertrophy, definitely not. That's not even close to big enough. Right ventricular hypertrophy, yeah, maybe. I'm thinking kind of a right bundle branch block right now, but maybe right ventricular hypertrophy. So what we talked about, wide QRS, bunny, your ears should be going up, looking for bunny ears. So if we go over here, RSR, RSR, yeah, bam, done. Like that is the right bundle branch block. And yeah, it's kind of got like this slow start, but it's not really as important. So let's take that. See how we did. So it looks like right, they had 50, I had 54. That's bradycardia. Left axis, yep. Long PR, agreed. Wide QRS, yes. I had normal QT, which they said there. I had question mark, right ventricular hypertrophy. He didn't. And then right bundle branch block. So yeah, the right bundle branch block is more the cause here than right ventricular hypertrophy. All right, next example, go ahead and take a quick pause to work through it, and then I'll start over here. All right, so let's do this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 16, 16 on, so 96. So close to tachycardia. Looks like there's axis is normal. So I look here, yeah, it's up. Here, it's kind of hard to say. So I look at lead 2, it's up, yeah, normal axis. Let's do rhythm. So rhythm looks like, yeah, PQRST, PQR. So PQR, or just RT, PRT, PRT. And there's nothing dropped, so it looks like a normal rhythm. Sinus. Rhythm. And then if we're looking at intervals, the PR looks like it's about, doesn't look too long, doesn't look too short, so it looks like a normal PR. QRS kind of looks a little wide here. Yeah, like we've got, and yeah, definitely wide there. So wide QRS. Ears are going up, we're looking for something. And then QT, it's about half, so I'm just gonna say normal QT. Hypertrophies, looking for hypertrophy, not much there. Yeah, probably not. So I don't think there's atrial hypertrophies. Ventricular, yeah, probably not. 1, 2, 3, 4, 5, maybe 6. Yeah, it's not enough. And then right ventricular hypertrophy doesn't look like it. So now we're on to bundle branch blocks. Well, we're seeing the M here. So with the wide QRS, left bundle branch block, mountain peaks. And yeah, you could look for other things too, but that's kind of indicative. And then these could just be, after the left bundle branch block, you're kind of done. So these are just changes associated with that. So let's have a look at the next page, see what they say. Yeah, I got 96, he had 90, normal axis, yep. Borderline PR, yeah, I guess so. Wide QRS, yeah, left bundle branch blocks over there. And then the QT was normal. Yeah, ECG reading done. So can't go further than that. All right, so next example. So again, I'll pause for a couple seconds. And let's begin. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10. So our rate is 60. Our axis is up. Up, yeah, left normal axis. Rate axis. Let's do the rhythm. So this really spiky thing, just by experience, I know it's probably a pacemaker. So pacemaker rhythm. So it's just a pacemaker. You could say it's a sinus rhythm, I guess, but it's definitely pacemaker driven. Probably look in the person's charts here, the pacemaker's implanted or something. And rate axis rhythm intervals. So intervals, I mean, this pacemaker is driving it, so it's probably coming from, you know, above, like near the AV node somewhere. It looks like it fires and then the ventricles are firing. So maybe like, I guess PR question mark, I guess you could say normal. It looks like it's just the pacemaker running it. QRS looks kind of wide. So here it's kind of deceiving. It looks like it's like, oh man, maybe it's like 2 boxes, but you can just tell it doesn't look nice and crisp. And as soon as you see it doesn't look nice and crisp, you're thinking it's just wide, it's just abnormal. And even here, you can look at, it's like 1, 2, it might be a little bit, it might be like just on the edge of that 3, but when you see this, it's just wide, it's just abnormal. QT, normal. Hypertrophy, you could look for hypertrophy. You're not going to see the atrial ones with the pacemaker there. Doesn't look like we're seeing ventricular. That's not really high. That's not really low. Right ventricular, probably not, because we're seeing bundle branch block stuff. So no. And then that wide QRS, again, our ears are going up. We're looking for something. See that the mountain peaks over here. So left bundle branch block. And that means our ECG reading is done. So let's have a look. So atrial paced rhythm, small electrical spikes at 60 beats per minute. Got it, normal axis, yep. So we have pacemaker, correct. PR, normally said, okay. Wide QRS, yeah. So then you're looking for the bundle branch block, which is over there, the left one. And that's it. So they said the right ventricle is being paced. So if they're sending the right ventricle, it's going to look like a left bundle branch block. Right, last example. So give you a couple seconds to pause the video and get started, and then I'll start. Right, so let's do this. So 1, 2, we'll add this one. 1, 2, 3, 4, 5. 14, so 14 on. So rate 84. Axis. Okay, so this axis is definitely not quite as obvious. It's really up in AVF, it's really up in lead 2. So it looks like it's going to be a right axis, but this guy is like, he's like right in the middle. Generally, if it's right in the middle, like you can see, it looks isoelectric, goes up and then down almost the same amount. Up and then down a little bit, up and then down. So it's probably a normal axis, but it's like barely normal. Normal axis. Okay, so let's look at the rhythm. P, P, Q, or PR, T, PR, T, PR, T. And there's nothing dropped. So yeah, it looks like a sinus rhythm. Intervals. PR looks really short. Like it's almost at the same time. You can look at it. It's like P and then the R is like starting immediately after. So short PR. And that should be cueing something in us. If you're seeing a short PR, something is off. And this isn't a pacemaker running it, so it should be something to do with the person. QRS looks wide. Just like this is a nice QRS over here. This is nice, 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 nice. But look at this guy. It's definitely not the same. It looks different. This looks wide. That looks wide. That one's definitely wide. Look at that. That's like almost like a full box. 1, 2, 3, maybe 4. So a wide QRS on the left side of the graph. So the first few seconds of reading. QT, pretty normal. Less than half. Well, I could look for bundle branch blocks here. Well, hypertrophies as well. So is there a hypertrophy? V1 doesn't really show us anything, so probably no hypertrophies from the atria. The left ventricle is not hypertrophied. It doesn't have those huge spikes. Right ventricle, no, probably not. This R wave isn't that big, and this is almost no S wave. Left bundle branch block, I don't see the mountain. Right bundle branch block, I don't see the bunny ears. So the last kind of thing on our list that we talked about earlier was the short PR, wide QRS. So we're thinking Wolff Parkinson White. So Wolff Parkinson White. So accessory pathway. All right. So rhythm 82. Okay, almost the same. 84. Is it normal axis sinus? Yeah, good. Short PR, wide QRS on the left side. So delta waves, yeah, over here. And then normal was later. So initially over here, we're seeing pre-excitation, which was the Wolff Parkinson White. All right, so that's the video, and hopefully that helps. And you can just feel free to watch the next one after.